So we are going to take a peek today at some of the possible things you could run into come this test. And again, a lot of combination, permutation, and or fundamental counting principle issues that can come up. So for instance, how many different combinations of sandwich, side, and beverage are possible? Straightforward. Sandwiches, I just looked to see how many options do I have. 1, 2, 3, 4. Okay, I got 5 of those. Sides, I got myself 3 options. And beverages, I look to have 4. So it looks like I'd have 60 different possible combinations possible on this. So again, if it's that straightforward where I can just put it in blanks, I can go ahead and do that. But I can change just a slight word somewhere and really change some things. How many different combinations are possible if you choose pasta salad? So we're going to use the same side and a sandwich and beverage. So you're like, okay, well, if I choose pasta salad, I'm not really getting any choices. It's like 1. But I'd still have my 5 sandwich options, and I'd still have my 4 beverage options. But my number of possibilities just went down from 60 down to 20, because now I have 1 less thing to choose from. How many total combinations don't include an apple? You'd be surprised. It actually is basically asking the same type of question, because you're like, well, I still got all the sandwiches to pick from, but don't include an apple, so I can't choose an apple as a side, but I still have 2 other options, and my drinks are all still the same, so I can work it that way. Most of these can work with the fundamental counting principle and would need to. Each question on a 6-question multiple choice quiz has A, B, C, and D answers. How many different ways can a student answer the 6 questions? So there's 6 blanks. And when you're taking a multiple choice quiz, there's no restriction as to which of the 4 letters it's going to be. So each time, I have 4 options. I mean, it could be it could be A, B, C, D, A, B, or it could be D, 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 D. We don't know. And again, I'm just multiplying them together. When in doubt on which thing to use, try the blank thing. If the blank thing looks like it could work, a lot of times it's going to. Bailey's looking for an outfit for school. Once she's chosen pants, she must choose from 12 shirts and 8 sweaters. How many different outfits with pants, shirt, and sweater can Bailey pick? Well, pants, it looks like she's only got 1 choice, so we're not, at least 1 choice that we know of. And we're just choosing from 12 shirts and 8 sweaters. And multiplying them up. Keep it simple. So you're like, are they all going to be this way? Because it seems like we're rolling that way. We'll get to some more options here shortly. But again, it's just anytime it's choices between the groups, we're just going to go ahead and multiply the values together using the fundamental counting principle. So just when we start getting to a place where we're feeling comfortable, now we start throwing some twists in. Stu wants to take 7 different classes next year. Assuming each class is offered in each of the 7 periods, how many different schedules could he make? 2 options here. First one is your order is going to matter. Excuse me. Because when you're taking classes, it's different if you're in algebra 3rd hour, algebra 6th. You know, you're going to be around different people and things. So you could, if you wanted, say, well, my first hour I have 7 picks, and then second hour I'd have 6 left, and then I'd have 5, and then I'd have 4, and 3, and 2, and 1, and multiply them together. But since your order would matter, you have another way of going about it, especially if you get, 20 selections and you don't want to do it that way. Since order matters, that would be a permutation. And I can get the same answer. 7 picks 7. But again, that's only when order matters can I do it that way. Otherwise, I'd have to do a combination or do it individually. How many different three-colored groups can be selected from a pile of 20 different marbles? Again, whether I pick black, then blue, then orange, or black and orange, then blue, it's the same 3 marbles. It's not going to matter. So here I'd use a combination. And those are the types of things that I'm trying to figure out here. Because if I did, well, let's do this first. Because here, if I were to do 20 times 19 times 18, because maybe you're saying, you know, they're each different, I get all these extra choices. But again, what's happening here on 6840 is that I'm taking in, like that 3-color combination I did before, I'm counting blue, orange, and green different from blue, green, and orange. And I don't need to. There's not a distinctness to them in this case. Because basically that would be me saying that it's a permutation if I did it that way. If I punched in 20 P3 for permutation, okay, so I'm saying the order matters, and I know it doesn't with these marbles, so that's why I can't do just the count them individually. I got to go to the combination on this one. Way to choose first, second, and third place. Does order matter this time? Yeah. So here again, I have the choice. I can either say, well, there's 12 people to get first, 11 to get second, and 10 to get third, and multiply them together. Or again, when order matters, if you like to go into speed demon route and say there's 12 people, I need to be able to pick the order of 3, but order matters, I get the same thing. So that's how some of these get to be interchangeable. The only time I have to go to the blanks, though, would be if, you know, I could repeat things, which we're going to get to. How many different 2-topping pizzas can be made if I have 8 to choose from? Which one is it this time? 2-topping pizzas. Does it matter if it's sausage and mushroom or mushroom and sausage? No. So let's see here. 8. Choose 2. And I sort of work my way through here. How many ways can we choose players for the first 4 batting positions? Okay. Does order matter this time? Any of our players? Yeah. If you're hitting leadoff or hitting fourth, it's different. It can have a different dynamic to things. So here again, I can either do, with my permutation, 9, I'm going to pick 4. Or you could do your 9 times 8 times 7 times 6. Either one is going to get you the same answer. Then we got Pearl here. She's reading 10 books. How many ways can she choose 4 books to borrow from the library for vacation? Does the order matter if she has a pile of books sitting there? Doesn't say they're on a shelf. Anybody? Yeah, order's not going to matter. You're like, the suspense is killing us. No, in boredom. Okay. So, 10. I'm going to choose 4 because my order's not going to matter this time. So 210 ways we can make that work. Now, here's our first situation where we get forced. How many passwords are possible if each password must contain 4 digits followed by 2 letters and no digits or letters can be repeated? Now, this is one where I definitely would go this route. Do I have to because I'm allowed Okay, I can't repeat, so that's going to change things up a little bit for me. So 4 digits can repeat. So I could use the same. No digits can be repeated. I gotta read this well. No repeat. So if I start with a certain number, I can't use it the next time. Then when I get to here, I can't use either of those. And when I get to my 4th digit, I can't use any of the first 3 that I already did. So I just kind of start counting down. Followed by 2 letters, the letters can't repeat. So 26 choices, and then 25 on the second. Now again, could I try to do this in pieces with like some sort of a permutation with both of these, since order when you're making a password absolutely matters? You could try, but again, I like trying to keep things simple when I can on this. It just seems simpler. What if the password can contain repeated letters and digits? Okay. So if I wanted it to be 1, 1, 1, 1, I could. And C, C, I could. It's going to give me a lot more options, though. So it's just kind of taking the topic that you're into, kind of focusing in on that a little bit. Issues as we head to the back. Ooh, our first open-ended question. Give an example of 2 independent events. 2 things where I could calculate probability and they have absolutely positively nothing to do with each other. Even get silly if you want to. Okay, I'll listen to both of you again here.
A rock falling and then a building collapsing.
Okay. Okay, so we'll run in some form with both of those. I'm still working on yours here. Okay, flip a coin and roll a die. Slightly different from falling from a building or it collapsing. I don't think there's a whole lot of options going with those. I guess it could be one of 2. It collapses, it doesn't, you fall, you don't. So we definitely could make that work though. What about 2 events that would be dependent of each other? There's one specific example I'm thinking of that we've actually done quite a bit with the probability. How can you do one thing and what happens next changes? One option may be drawing 2 cards without replacement, because once I take the first card out, I just change the probability because I have fewer cards to deal with now. Or maybe you think about maybe the marbles in a bag. Draw your hand into the bag, pull a marble out. I keep it out, but now I draw in again. That would change the probability of those. So that's a couple of things to consider a little. So then, now we start getting into more of the more recent type things. So in our school library, we got 7 algebra books, 8 geometry, and 5 statistics. Or in other words, 20 total books. Carlos is going to select 2 at random with replacement. So find each probability. So it's probability of getting algebra and then statistics. Take them separate. Probability of getting algebra would be 7 out of 20. Then Carlos takes it and he puts it back on the shelf. And then he draws a statistics book, which would be 5 out of 20. And then I just multiply those together and reduce the fraction as far as I can. Okay, so the with replacement is the big thing here. Because if it wasn't, bless you, that would change quite a bit of what I'm doing. both geometry. Again, they're going to be with the replacements separate events. They're independent. So I got 8, oops, not 8 out of 80, 8 out of 20, and 8 out of 20 again, if they're both geometry both times. And again, I just multiply them together and reduce. The only real thing I think in this section that could possibly get some of you is just not being careful with the word like not geometry. So it's, for instance, if there's 8 geometry books, there's 12 that aren't. But again, I'm still putting the geometry book back, or the non-geometry book, and then getting the statistics. Sort of like our both geometry, statistics, and statistics. It's still 5 out of 20 each time with the replacement. And I can get that worked out that way. Same idea coming on the next one. Cora's got 15 pencils. Okay, we get a total this time. 9 have erasers, 6 do not. She takes 2 pencils from her desk, one at a time, without replacement. I'm going to lose whatever that first one is. So the probability of getting one with an eraser is 9 out of 15. But there's 6 without, but now one of the ones with an eraser is gone. So it's now only out of 14 now. And then again, I'm just putting it in the reduced form already. Both have erasers. The first one's always going to be 15 in this section. But now it's 14, but also be careful. Since the first one was taken out with an eraser, and there were 9 of them, now there's only 8. So a little bit of logic goes a long way with some of these. Both without erasers, okay. So 6 of them don't have erasers, but now that I already have one out, now there's only 5 left that don't have erasers. And I can get my answer from there. And then finally, with an eraser, okay. Then without a point. Wait, what? Without a point? Nothing about points in here. There's the oddball. So read carefully to see if it's some situation that can't happen, it just is going to turn that into 0 for me. Number cubes rolled twice in a row. What's the probability of 4 on the first roll and an odd number on the second? Well, they're independent of each other. 4 on the first roll, 1 out of 6. Odd number on the second, 1 out of 2, or you could use 3 out of 6. Keep it simple, keep it simple, keep it simple. Josiah's teacher announced 2 people are to be chosen from the 22 students, 14 girls and 8 boys to represent the class. What's the probability that a girl will be chosen first, then Josiah is chosen second? So you're like, ooh, this ought to be interesting. Let's see. How might we want to tackle this one? Any ideas? You're like, well, let's see. Is our order going to matter? Well, when it says the probability that a girl will be chosen first and then Josiah second, now we've got to look. If moving the item changes the situation, we've got to use the fundamental counting principle. And it does here because it talks about the girl being chosen first. So we're going to go with blanks. So the girl being chosen first, There's 14 girls out of 22 total students. But then I've got to be careful. Josiah, there's only one Josiah. So we've got 1 out of the 21 kids that would be left. And I believe, I want to make sure though. Yep. Okay. So once order starts to matter, that's when I have to start going to my other options. If it would just said 1 boy and 1 girl, wouldn't have mattered. I could have gone the combination route, but that's what I have to determine here. Okay, debate team has 17 members. How many ways can 11 members be chosen to go to a debate? Doesn't talk about who's doing what job or anything. So my order isn't going to matter this time. So this time I can go the combination route. And get lots of choices. And again, as we're doing these, 10 girls are trying out for the high school musical. How many different ways can 2 girls be chosen to play, not play, a mother and daughter, distinct roles? Again, I have an option. I can either be like, okay, so mother and daughter, I have 10 choices for the first and 9 for the second. Or I could say order matters. I can do 10 permutation too. Either one's going to get me to the right place. Anytime order is going to matter, you have an option of going to a permutation. They're both going to get me to the same place, like I just said. This next part we didn't chat about a whole lot during the unit, so I want to really kind of bear down here for a minute. Discrete versus continuous data. Okay, discrete is areas where we'll literally sit and count. You can count people. You can count the number of cars in the parking lot. Those types of things. Continuous data is something that we normally do and we measure. And when I say measure, it's things where we can start getting into any type of value that might happen to come up. I found an example that I liked on here, so I wanted to kind of run to this. Okay. Discrete data takes certain values. The number of students in class, I can't have half a student. Okay, I can't get into that minuscule detail with discrete data. It's larger things. Continuous, though, I can take any value, and it doesn't have to be infinite. It can still be within a range. But my height could be 5 3/4 of an inch, and somebody else, there's little tiny pieces that I can take, quarters of inches, millimeters, whatever. Time in a race to thousandths of a second. Okay, that's continuous. That's not something we're just going to count off the top of our head. We're going to have to measure it. Okay, weights, lengths of things, stuff like that. So with that in mind, let's start with the easier one. The population of a city, discrete. We definitely can count people. They're all whole people. Okay. Now we'll go back. The amount of RAM on a computer. Ooh, and here comes the split. I lean towards the continuous one on that one because, and here's my reason for this, because I was ready for this argument too. If you have a computer going and it starts talking about your random access memory, it'll start talking down to, less than full gigs how much you have left. And that changes constantly depending on what you have on your computer, how many different activities you're working with, stuff like that. So that can change lickety-split and not just be whole numbers. So that definitely would be continuous. The mass of a banana. Continuous. Because again, that's measurable. And the temperature of water. Continuous, it's measurable. All right. Feeling better with that. So back to our regularly scheduled probability. A bank contains 3 pennies, 8 nickels, 4 dimes, and 10 quarters. Looks like 25 total coins. 2 coins are selected at random. Find the probability of each selection. So, one of the things we talked about before with this is going in and say, oops, got a little too low. 2 pennies. Here I got 3 pennies that I could possibly choose. I need 2. But my total number available would be the 25 coins. And I'm going to pick 2. So, you swing over. So 3 pick 2 doesn't give me a lot of options. So 3 out of 300, or 1 out of 100. Now on that one, because sometimes people go, well, wait a minute. On that one, couldn't I have just done the blanks? Well, let's find out, since we're kind of in a creative mode today. I could look and say, well, I've got 3 pennies out of 25 if I was going that way. And then if I picked one, I'd only have 2 left out of the 24. You can. But here's kind of the caveat. Here's the danger. That only works when you have 2 of the same thing or 3 of the same thing. Once I start changing values, quarter and a nickel and a quarter, things like that, I have to stick with this because now I'm going to start getting into order issues otherwise and counting the same thing more than once. And I don't want to do that. So here with a quarter and a nickel, I have 10 quarters, I want to pick 1. I have 8 nickels, I want to pick 1. But I still have 25 coins in total, and I'm picking 2. So that's the way that I'm going to want to break this one down. And I'll get you to what the answer should be at the end here, so we can get you situated with that. But that's our big thing with these. Whenever you're getting into the probabilities with different items, you want to watch to what you're getting yourself into. A nickel and a dime, same idea. 8 nickels, 4 dimes. Still, I'm doing 25 and picking 2. And get my solution. And then finally, the twist. 2 dimes and a quarter. I'm only selecting 2 coins. This would be 3 coins. I have 0 chance of getting 2 dimes and a quarter when I'm only selecting 2 coins. And then one last thing that's got a little bit of a straightforward, but I started to look through things and I wasn't sure how often I saw if I saw this anywhere with things. So this could be something that's a little bit new at the end. Finding expected value. Finding expected value just means you're going to see what you would get out of something at the end. For instance, value of the different cards and how often they happen out of 50. So what I'm going to do is I'm going to take the value of whatever that event is, and I'm going to multiply it times the frequency of that particular event happening. So like here, for instance, my card value is 1. My frequency would be 6 out of 50 because there's 50 cards. And then I'm going to add the next card value times its. Gamblers like to use this to see if they can weight a game their direction, whatever it happens to be. So for each one, I'm just going to multiply the frequency as its probability, because again, I have to know that part. And I have to do that all the way down to the end. And I'm almost there. And once I have that set up, I'm actually going to multiply that out. And what this will tell me is, it's not going to give me one of those exact card values, but if I were to do this over and over and over and over, it's like experimental probability. Well, this would actually turn into somewhat theoretical. I'm going to find out what value I'd expect to end up with over time. So this is actually the most tedious process of it all. Oops, not 52 though. That would mess things up. Harty, mercy. Start blaming the calculator. And we're finally to the end. And I have all 50s, yes. And this we normally take as a decimal. So for instance, if you were to draw a card from this special deck with those values and those frequencies, you drew 50 cards and you wrote down all the values and took the average at the end, that typically would be the average that you would get at the end, about 3.86. Again, this unit quest itself is going to be set up basically the same way. Same types of questions and things like that.